Well, hello everyone. Here's your Sioux Falls physics teachers looking today at a relationship between calories and work. We have a 45 kilogram physics student, and she is attempting to climb stairs to work off a chocolate bar of 275 calories. How high must she climb? Well, let's start by taking a look at the amount of energy that she wants to work off. Notice that chocolate bar, if you kind of look on the back, the nutritional information there, you'd find 275 calories. So that is the work that she will need to do to work off that energy. But notice that when we say 275 calories, and this is how you would see it on the back, that C is capitalized. Okay, a food calorie is really a kilocalorie, and we often show that with a capital C. So if it is 275 calories, that is actually going to be 275,000 little calories. Okay, and you can see that again when we look at our conversion factor. The conversion factor is shown 1 little calorie with a lowercase c is equal to 4.184 joules. So that candy bar has 275,000 little calories. Here we can do our dimensional analysis then. Little calories multiplied times the conversion factor of 1 little calorie is equal to 4.184 joules. And working that out, then we find that the amount of work that she needs to do is actually incredibly large. 1,151,000 joules of energy are contained in that chocolate bar. Okay, now we want to figure out then exactly how high that would be. And of course, at this point, you're probably getting the idea that that's going to be a reasonably high number. Remember that work is equal to force times distance. And if that force is coming from gravity, as it would be if she's climbing up steps, then that could be replaced with mass times gravity. So now we have that really big amount of work. We'll fill that in as the amount of joules. Okay, her mass was given as 45 kilograms. The acceleration of gravity is 9.8. And that allows us to solve for D. And of course, if we plug in the values that we know, our final answer for D, or the height up the stairs that she must climb, is 2,600 meters. So that is why you wouldn't want to ever attempt to just directly work off that candy bar only by climbing up steps. Takes all the other calories that we use as well to work that off in the end.
Hello again from the Sioux Falls physics teachers. Today we're going to look at the problem of heat and energy. Turns out the person who did this was a guy named James Strules. He's considered the father of the concept of energy conservation. At the age of 19, he equated both heat and mechanical energy. The process by which he did this was to calculate the change in temperature of 10 kilograms of lead shot as it fell from a height of 3 meters. Let's go ahead and calculate what that change in temperature is. Now, the idea here is that work and heat must be the same thing. In this case, the type of work is a change in potential energy. Gy initial M minus Gy final M has to equal MC delta T. We're looking for that delta T, the change in temperature. Now there's some important things to know. If we pick our frame of reference right, our final height will be 0. So we can just get rid of that term. Our initial height is 3 meters, and our gravity we know. But also notice that mass is in both terms, so we can cancel that out also. This leaves us with gravity times our height equals the specific heat times the change in temperature. In other words, the change in temperature is simply gravity times the height divided by the specific heat of lead shot. Now, let's go ahead and start plugging in. That change in temperature, delta T equals 9.8 times 3 meters, all over the specific heat of lead shot. I didn't give you the specific heat. Where would you find it? The answer to that's easy. It's in your book on page 335. And if you look it up, you're going to realize that it's 128 joules per kilogram degrees Celsius. If we go ahead and solve this, we end up with a specific heat that is equal to 0.23 degrees. Now this can be either Celsius or Kelvin because the equation, the degrees, size of the degrees is the same for both. I prefer Kelvin.